What I can do, I can start by just going through the agenda. So first, I would just like to say welcome. So my name is Åke Rosenqvist, and I represent JAXA and the Committee on Earth Observation Satellites, CEOS, here, where I'm helping to coordinate the CARD4L SAR activities. So at the webinar today, this is the second of the two webinars. And we have the agenda here in front of you. So after a short welcome, when we are waiting for people to come in here, we will start with an introduction to the CEOS analysis ready data by Steve Laban, who is the one of the co-leads of the CEOS Land Surface Imaging Virtual Constellation Group. And then I will provide an overview of the CARD4L for SAR. Then we have Tom Logan from the Alaska Satellite Facility, followed by Amy Parker from CSIRO Australia, talking about CSIRO plans for CARD4L with Novasar S-band. Followed by Brian Kilo from NASA and the CEOS System Engineering Office, who will talk about CARD4L and the Open Data Cube. We have Pang Yuan from Geoscience Australia and Digital Earth Africa. We'll talk about the Sentinel-1 CARD4L activities there, followed by Marko Repce from Synergize in Slovenia, who will talk about the CARD4L development at the Sentinel hub. And then finally, I will give a presentation about JAXA's global L-band SAR mosaics and the efforts to make them CARD4L compliant. And then the last half hour, we have open discussions and questions and answers from the floor. So please use the Q&A window for any questions that you want to pose. And we will try to answer those online here live this last half hour. But what we have done here is that we have actually pre-recorded all the presentations just in order to stay on time. So following Steve's introduction here, which will be live, we will then convert to these pre-recorded presentations that we will run through, and then we will come on live again and answer the questions. All right, Steve, I think we're almost at 5 past exactly now, so I'll give the floor to you.
Yeah, terrific. Thanks, Åke, and greetings, everyone. Again, my name is Steve Laban, as Åke mentioned. I'm with the U.S. Geological Survey, USGS, and I'm one of the 3 co-leads for the CEOS Land Surface Imaging Virtual Constellation team. And today it's my great pleasure to be introducing this webinar. Since kicking off the discussion on analysis-ready data in CEOS back in 2015, we've really seen a lot of great progress being made from initial idea to a definition, now to a family of specifications, and now even into this year, introduction of the USGS Landsat Collection 2. We've got a global set of global products out there that meet the specifications in a cloud-enabled environment. So seeing a lot of great progress. And as many of you already likely know, the term CARD4L, it's short for CEOS, Analysis Ready Data for Land. And even agreeing on that name itself was a multi-day meeting in LA, Los Angeles, under the flight paths of the airplanes at LAX. So that it's taken us a little while to get here. But overall, really, those of us that have been involved from the start have seen really great progress, including, as I mentioned, the release of USGS Landsat Collection 2, which meets those specifications for CARD4L, as well as many more CARD4L compliant products that are currently in the pipeline. And you can go to our website and start seeing some of that as well. You know, and this continuing progress is not driven by just evangelizing few who have been imposing an approach, but rather it's being driven by people in a range of different roles and interests seeing the strength of this idea and subscribing to it by committing time and energy to shape it and moving it forward. And I guess nowhere has this been more apparent really than in the radar community. So we really applaud OK's wonderful leadership and the benefits we've seen from this group. OK Explain there's really a kind of a cutoff here in 5 minutes, so I'm going to try to be brief and kind of to the point here. First of all, for today, what do we want? Really, we're looking for this forum to inform you about CEOS's activities to develop specifications for CEOS analysis ready data for land. And here in particular is to present the CARD4L specifications for synthetic aperture radar products. And as part of this, we want to clarify the differences really between CEOS analysis ready data and other analysis ready data products. And then finally, really to provide some testimonies from organizations and groups that are developing products that are compliant with the CARD4L SAR specifications, such as the Open Data Cube, ASF, CSIRO, Digital Earth Africa, and Synergize who are on this webinar today, including their motivations, experiences, and the challenges that they've experienced. We hope this will be useful to you. The material today is primarily targeted to SAR data providers and mission operators, including not only CEOS agencies, but also commercial entities, but also to the more general SAR data user, including non-expert users who may be interested in using SAR data for the very first time. What we hope you get out of this seminar or this webinar, we really, amongst the general users, we hope you have an increased awareness really of the benefits of the CARD4L data, in particular with the SAR products. And amongst the SAR product data providers and mission operators, really gain a better understanding of the CARD4L concept, as well as the specifications themselves, hopefully leading to an increased interest in providing CARD4L compliant products, as well as looking forward to harmonization with other CARD4L compliant products into the future. So I'd really like to thank you in advance for attending, extend my thanks on behalf of CEOS to those organizers and panelists here today. So thanks everybody, and back to you. Okay.
Thank you very much, Steve. Right on time. Perfect. Then we will just get started with the first presentation. And that will be myself giving a short overview of the CARD4L SAR aspect. And let me also say, in the chat window, you can see that we have posted a link to the Normalised radar backscatter specification document. So if you click that link, you can download the document, the PDF, and you can have a look at it while you're listening to this webinar. And maybe you will come up with some questions about that, and you will understand it a little bit better. So please, yeah, Matt, you can fire up my presentation now. So good morning, good day, and good evening again. My name is Åke Rosenqvist, and I represent JAXA and the Committee on Earth Observation Satellites, CEOS. On behalf of the SAR expert colleagues listed here, I will provide an overview of CEOS analysis ready data for land, CARD4L, product specifications for synthetic aperture radar. So what is analysis ready data? ARD is a term that is widely used by satellite data providers. A common definition is lacking, but it broadly refers to a data product that is provided at a processing level that accommodates utilization for the application that the data provider in question has in mind. Without coordination, however, it follows that while ARD products from one data provider can be expected to be internally consistent, ARD products from different providers most probably cannot. The lack of common standards is a lost opportunity for interoperability. CEOS analysis ready data for land, CARD4L, is a joint effort by CEOS to develop a set of well-defined ARD specifications that data providers can opt to include in their suites of satellite data products that they offer to users. A CARD4L product is defined as satellite data that has been processed to a minimum set of requirements and organized into a form that allows immediate analysis with a minimum of additional user effort and provides interoperability both through time and with other data sets. One specific objective of CARD4L is to broaden the Earth observation user community by provision of data products that do not require expert knowledge to ingest and analyze. And this is perhaps particularly relevant for synthetic aperture radar, where the potential to contribute to today's great environmental challenges with unique information is significant, but with the SAR user community remaining very small and expert-oriented even after 25 years of operational SAR missions. To date, there are 4 CARD4L product specifications for SAR products. Normalised radar backscatter, NRB, which is a backscatter-only product, as the name indicates. It is the most basic and commonly used radar product, suitable also for users with little or no experience of SAR data. Polarimetric radar, aimed at users interested in exploring radar polarimetry. Geocoded SLC, which are specification for geocoded complex data, aimed to help non-SAR expert to do INSAR applications. And the Interferometric Radar, specifications for interferometric products using 2 or more SAR images as input. I will provide a brief description of the 4 SAR specifications in the following slides. So first of all, what does the CARD4L specifications look like? The specification documents, referred to as product family specifications, can be seen as guidance documents for data providers that aim to develop CARD4L compliant SAR products. The CARD4L specifications, they detail threshold and target requirements for geometric and radiometric corrections, general metadata, as you have an example here on the left side, and also per pixel or image metadata. In order for a product to be approved as CARD4L compliant, all threshold requirements must be met. For the NRB, for example, there are 44 requirements specified. Target requirements are optional for the data provider. Starting with the CARD4L Normalised Radar Backscatter NRB product, this is an example of what a CARD4L NRB product could or should comprise. First, it's the actual sensor measurement data. In this example is the radar backscatter images provided as radiometrically terrain corrected gamma naught images for each of the polarization bands. Then we have general metadata with all the relevant information about the data take, the processing steps, the geometry and the radiometry of the product, provided in the format that is both machine readable and readable to humans. Then we have per pixel metadata, which are image data in the same geometry as the measurement data, including, for example, data, no data, mask image, local incidence angle, and scattering area image. Depending on the data provider, the per pixel metadata may be selected on demand by the user, or for pre-processed product maybe consist of a fixed selection of per pixel metadata. The second product, Polarimetric Radar, it comprises 2 different product types. The first is a polarimetric decomposition product, which is comparable to the standard backscatter product, but where the polarimetric information has been enhanced, for instance, to separate different scattering mechanisms by the use of various decomposition techniques. Which decomposition to include is not prescribed in the CARD4L specification, but for the data providers to decide themselves. The second pole product is the polarimetric covariance matrix, which is a set of complex images from which the full polarimetric phase and amplitude can be derived. It is for a bit more advanced users and can be applied, for instance, for polarimetric time series analysis and pole INSAR applications. The CARD4L polarimetric radar structure is based on the NRB structure with similar requirements for geometric and radiometric accuracy and general and per pixel metadata. Then the Geocoded SLC. First of all, singular complex, that's the standard level 1 SAR image product, very well known. It comprises of information about the amplitude and phase of the received radiant energy, provided as a complex number. SLCs are given in slant range geometry and require additional processing software and a fair amount of radar expert knowledge to be used. Then the CARD4L Geocoded SLC product, on the other hand, it's an enhanced pre-processed version of the SLC that describes the complex radar signal at each point on the ground surface with all average propagational phases removed, so that the amplitude and phase values represent the properties of the ground surface only, without influence by the radar instrument. CARD4L GSLC products are presented in a common geographical coordinate system, such as, for instance, UTM or geographical coordinates, rather than in a slant range radar coordinates to facilitate use by non-radar specialists. The CARD4L GSLC product specification is still under development, and we expect it to be completed within the next few months. Then finally, the Interferometric Radar, INSAR product. It specifies a suite of 3 products that are generated by INSAR processing of 2 observations of the same geographical area at different times. Wrapped interferogram is an image showing the differential phase signals between 2 complex images. The signal is wrapped in quantities of 2 pi radians, giving an image with fringes. The unwrapped interferogram is an image where the wrapped fringes have been added up to give a continuous phase signal across the entire image. There are different approaches to do this unwrapping, and CARD4L does not prescribe which method the data providers should use. Finally, the interferometric coherence is an image of phase coherence between 2 SLC images. The CARD4L INSAR product specification is also still under development and expected to be completed in the second half of 2021. So what are the steps a data provider needs to go through in order to have a product approved as CARD4L compliant? Well, the first thing is to download the latest CARD4L specification from the CEOS ARD website. Then undertake a product self-assessment with respect to each of the different CARD4L parameters and indicate the compliance status, whether it's compliant, threshold compliant, or target compliant in the CARD4L checklist that is attached to the CARD4L document. Next step is to rectify any non-compliant parameters or issues. And once all parameters are deemed to be compliant at either threshold or target level, then contact the CEOS LSI point of contact, who will initiate a formal peer review by the CEOS working group CalVal. And then products passing the working group CalVal review will be considered CARD4L compliant. A number of satellite data providers are working to develop CARD4L compliant SAR products at the moment to include in their product catalogs. We will hear now from a few of them here today in the following presentations. Thank you very much for your attention. Okay, thank you very much to myself. Great presentation. All right, let's move on then. So now we have a number of data providers who are in different stages of CARD4L development. And we'll start with Tom Logan from the Alaska Satellite Facility. So you can fire up Tom's presentation. So Tom is online here.
Hi, this is Tom Logan from
presentation here. Yeah, go ahead.
From the Alaska Satellite Facility. I'm here today to talk to you about CARD4L readiness at the ASF Distributed Active Archive Center. Specifically, I'll be referring to the ASF On-Demand RTC products. The ASF on-demand RTC products are processed using Gamma software and available through ASF's search engine. They include normalized radar backscatter that's both geometrically and radiometrically corrected. They're on a 30-meter posting so that there's no resampling required to compare one pass to another. The GeoTIFF products are readable by GIS systems out of the box and include ArcGIS-specific XML metadata files. There is also a dynamic README file in a markdown format that includes details such as the DEM used in processing and processing options. These options include things such as sigma naught versus gamma naught, power versus amplitude, an enhanced Lee speckle filter, and DEM matching. The suite of products includes the DEM used in processing, the local incidence angle map, and the layover shadow map optionally. Of course, they also include the actual radar backscatter in both poles. In addition to the on-demand products, we have an ArcGIS toolbox that allows users of ArcGIS to easily manipulate these output products. Users of ArcGIS can use the toolbox to unzip, do scale conversion, classification, change detection, and RGB decomposition. We are somewhat deficient in meeting CARD4L requirements. In general, metadata is not particularly machine readable. It's in a README file that's text. We're missing quite a few of the fields. We have less than half of the 70 fields that I counted. As far as per pixel metadata go, we're missing one of the required data layers. That's the combined mask image. But we do have the individual pieces. We just need to put it together. We're also missing the 3 other data layers that were requested. As far as geolocation goes, we have not done a thorough analysis without DEM matching turned on, which we currently have turned off. We're trusting the Gamma software and the advice of the field experts that say that Sentinel-1 orbits are precise enough to get good results. In order to become CARD4L compliant, we would need to, at a minimum, implement a metadata file that's machine readable, populated with all the metadata fields, and following a metadata standard. We need to add a comprehensive mask image, which would include valid, non-valid, no data, as well as layover, shadow, and water. Currently, we have 5 of 6 of those. The only one we don't have is the water. We need to perform a thorough geolocation analysis. That 0.2 pixel threshold seems a little stringent, but we're not sure whether we'll get there or not. We're going to use ground truthing and time series analysis in order to do that. We are moving towards compliance with CARD4L, looking for the best strategies to keep us moving forward. Currently, we're evaluating NetCDF versus cloud-optimized GeoTIFFs for each layer. We're going to adding the missing optional layers. And we are considering creating all the files in NetCDF and allowing for on-the-fly conversion to cloud-optimized GeoTIFFs via the user interface. The products will include CARD4L compliant stack item JSON and the ability to archive on-demand products and ingest into a stack catalog. Currently, we are not archiving our products, but we may be able to do so in the future. Thank you for your attendance. For more information, you can contact ASF at asf.alaska.edu or access the on-demand products at search.asf.alaska.edu. And to access the ArcGIS toolbox, asfalaska.edu, how-to, data tools, GIS tools. Again, thank you for your attendance.
Thank you very much, Tom, for that one. And I noted that there was somebody sneezing in the background exactly at the same time as there was this morning. All right, so we'll move on to the next presentation, which is Amy Parker from CSIRO, who'll talk about CARD4L plans for, or CSIRO plans for CARD4L distribution of NovaSAR 1 S-band SAR data. Amy, please.
Hi, my name's Amy Parker and I'm based in the Centre for Earth Observation in CSIRO, the Commonwealth Scientific and Industrial Research Organisation based in Australia. I lead our NovaSAR activities, and this includes a team who are working to develop NovaSAR CARD4L products. That team includes Yengshu Zhu and Eric Lehman from CSIRO, plus our host today, Orke Rosenquist. NovaSAR is an experimental low-cost satellite mission developed and operated by Surrey Satellite Technology Limited in the UK to provide a new source of low-cost satellite synthetic aperture radar imagery. The mission operates on a capacity share basis, and back in September 2017, CSIRO joined the NOVASAR mission partnership on behalf of Australia. That meant that we secured a 10% share in the acquisition and tasking capacity of this new satellite mission. Significantly, NOVASAR is the only spaceborne SAR sensor operating in the 3.2 GHz or S-band frequency range, and that makes it an important addition to the current suite of international civilian SAR satellites. Australia is one of the largest users by volume and variety of space-based Earth observation data, but historically Australia has actually lacked a sovereign civilian Earth observation satellite capability, and there's also relatively limited experience in the use of SAR. For Australia, the NOVASAR partnership therefore presents an opportunity for us firstly to gain experience in satellite operations and tasking, and secondly, to build new national expertise in SAR remote sensing. CSIRO are operating Australia's share in NOVASAR as a national facility for the benefit of science and research. This means that we are providing the data free and open access to the international user community. This is a key motivation in our decision to provide NOVASAR data products in CARD4L format. The national facility aims to maximise the impact of the NOVASAR mission and build a stronger SAR capability for Australia. This relies upon ensuring that the users have access to the tools and products that are required to work with this new source of EO imagery. CARD4L products simplify SAR for non-expert users and will support uptake of NOVASAR data, particularly in Australia, where experience with SAR is limited. NOVASAR is also a technology demonstrator mission, and CARD4L will remove obstacles such as new data formats and the limited compatibility of the data with SAR processing softwares. In going straight to CARD4L, we are also seeking to support CEOS CARD4L activities and Australia's involvement in CEOS. Initially, we will produce the Normalised radar backscatter gamma naught product only, plus the product metadata and the per pixel metadata, including the data mask image and local incidence angle image. All of this will be compatible with CARD4L product family specifications for the Normalised radar backscatter product version 5. To date, our focus has been on the selection of parameters, for example, the DEM, pixel spacing, calibration factor, and the format of the data. The development of product and metadata workflows is now nearing completion. In March of this year, a set of sample products will be made available, and then we will go through a process of self-assessment, applying the workflows to the back catalogue of data that's already been acquired. In quarter 3, the CARD4L products will be distributed alongside the L1 data to users. The Level 1 and CARD4L products will be distributed free and open access to users via an online data hub system. And this data hub system is built based on the ESA Copernicus Sci-Hub, so it probably already looks quite familiar to you. Most imagery will cover Australia, but of interest to the international community will be S-band data that is coincident with the Surat Basin Corner Reflector Array, and also other sites that have extensive open access ground truth data that's accessible via the Terrestrial Ecosystem Research Network, TERN. To summarise, CSIRO are operating Australia's share in the NOVASAR mission as a national facility for science and research, with the objective of building new SAR expertise in Australia and also stimulating research with S-band SAR data. We see CARD4L as playing a significant role in meeting this objective, and we look forward to sharing the Normalised radar backscatter products with the community throughout 2021. For any more information, for suggestions or questions, please do reach out or visit our website. Thank you for listening.
Excellent. Thank you very much, Amy. And I think it's really exciting to have an S-band SAR in orbit, and also great that CSIRO is providing the data over Australia free of charge for that one. Let's move on with the next presentation. Now we have a group of 3 presentations by Brian, Fang, and Marco that will deal with the CARD4L SAR consideration for the Open Data Cube and Sentinel-1 data. So, Brian, please.
Hi, my name is Brian Killow. I work for NASA and I lead the CEOS Systems Engineering Office. I'm happy to be here today, and I'll be presenting to you the CARD4L SAR considerations for the Open Data Cube. So what is the current state of analysis-ready Sentinel-1 data? As many of you know, CEOS is working on a specification for normalized radar backscatter, and that has already been approved. So there's several global sources of processed Sentinel-1 data, and I have a few of those listed here. The most obvious source is the Copernicus Hub. That's where the core data comes from in the beginning. Users can download and process that using Sentinel Toolbox. They can use other processing tools like Gamma or the DAS services. Alaska Science Facility is another source where you can download and process the data using the HYPE processing tool, which is in beta testing. Google Earth Engine has NRB data with geometric terrain correction, but it does not include radiometric terrain correction, which can be an issue if you're using the data in high elevations. And then finally, and most recently, a Sentinel Hub CARD4L tool. Our office, the CEOS Systems Engineering Office, has been working with Digital Earth Africa and Synergize to develop this tool, and the products there are going to comply with CARD4L specifications, and I'll have more on the next chart. The link for the Sentinel Hub CARD4L tool you can see on the right underneath the screenshot there. Feel free to go visit that. If you have any questions, please contact me and I can tell you more about it. The project was initiated late last year to develop this pipeline. Digital Earth Africa is using it to develop the pipeline for all of the data in Africa. I'm using it to support Open Data Cube projects around the world and provide core data sets for those users. So the pipeline gets the data from Copernicus Hub, processes it on the Amazon cloud, and then delivers the products into a temporary AWS S3 storage bucket. One thing to note is that we're using also the Copernicus DEM for digital elevation model and for doing the terrain correction. So at that point, once the data is in a bucket, the users can download it or they can migrate it and push it over to their own cloud storage location. So for instance, if they have their own AWS account, ultimately we'd like them to pull it out of there. So it's just a temporary storage. These products are radiometrically calibrated into gamma naught format, and then they also include radiometric terrain correction. All of these things are compliant with the specifications in CARD4L, and then the output is in a 1 by 1 degree tile. The VV and VH bands are separated, and there's general and per pixel metadata included. So where do we go next with all of this work? There's an effort in progress to compare the data from Google Earth Engine with the data that comes out of the Sentinel Hub tool. This is going to be the focus of a 2021 IGARS paper. George Dyke and OK Rosenquist and myself and Yuan from the Digital Earth Africa team are all part of that effort. We're working with Synergize to complete a peer review of the CARD4L process so that it gets full stamp of approval. And we're also testing a number of data cubes for comparison around the world. I just recently created one in Virginia, about a 1.4 terabyte cube dating back to 2017 of all the Sentinel-1 data for coastal Virginia. I'm also working with the potential for the Pacific Islands, looking for a data set there for Vanuatu and Fiji, working with the South Pacific Consortium. We'll be working with other partners around the world to develop and test sample data sets, so contact me if you're interested in testing any of those. You can also contact Grega Milczynski directly at Synergize, and if you have any plans for larger data sets or if you'd like to consider your own pipeline based on what we've done. So finally, one thing that's also working on the sidelines is that we have a desire for Copernicus to create a standardized CARD4L data set. Everything we've done here is really just meant to be prototype, but what we'd like to see is the Commission take this on with ESA and to create this as a regular data product. So we've prepared a letter from CEOS requesting this with some details of why we believe it's important, and that process has just begun. Thank you for your time. Hi, my name is Brian Killow. I work for NASA.
Once is enough, huh? Thank you very much, Brian. Very good. We'll move on straight to Yuan, who will give the background to the development of Sentinel-1 CARD4L NRB backscatter for Digital Earth Africa.
Hello everyone, my name is Fang Yuan. I'm an Earth observation scientist from the Digital Earth Africa establishment team. It's a great pleasure to be here today presenting with my colleague Marco Repscher from Synergize. We'll be talking about our experience developing a Sentinel-1 normalized radar backscatter product for Africa and also applicable worldwide. So why did we start doing this for Africa? Digital Earth Africa is a program in its establishment phase funded by Hemsley Charitable Trust in the US and Australian government. We're building a platform where we are going to use Earth observation data to help address challenges of sustainable development in Africa. I'm based in Geoscience Australia in Canberra, but I'm working with team members across the world, especially people in Africa, so to make sure that the program is going to be led by African team in the future for Africa. So in a nutshell, we want to turn large amounts of Earth observation data taken by satellite into information products and insights that can help achieve impact on the ground. For example, for resource management or for food security. In order to do this, we can't rely on Earth observation specialists. We need as many talented people as possible to be able to work with these data and gain insights from them. Therefore, we work with analysis-ready data. D-Africa has planned to host 3 complementary datasets, Sentinel-2, Landsat Collection 2, and Sentinel-1. They're either endorsed by CEOS as analysis-ready data already or going to be assessed soon. We also believe that these datasets have to be accessible and optimized for analysis. So we provide data in the cloud, in cloud-optimized GeoTIFF format, with metadata that's compliant to spatial temporal asset catalog. By adopting these standards, we hope to maximize interoperability and discoverability. Also, thanks to the AWS Public Dataset Program, these datasets are going to be hosted in Cape Town in the African continent. Out of the 3 datasets I just mentioned, Sentinel-1 is a particularly exciting one for me. It is a large-scale time series SAR dataset. It's going to be critical for monitoring the tropics, and it offers different measurement of the land surface compared to optical sensors. Unfortunately, all the Sentinel-1 datasets that are freely available now are not analysis ready. You need specialized SAR knowledge and special software to pre-process them before you can use them. So we decided to tackle this problem ourselves, and I'm really grateful that we find Synergize to work with us with well-aligned interest and a capability to make magic happen in the cloud. Together, we set on this journey to produce a continental-scale Sentinel-1 normalized radar backscatter product that's compliant to the latest CARD4L specification. Now I'm going to hand over to Marco Repscher to give you more detail about this process and show you the tool they have built. Thank you.
Thank you very much, Fang, for that. And we'll fire up Marco's presentation immediately here.
Thank you, Fang. So Marco here, I'm from Sentinel Hub, and today I'd like to say a few words about CARD4L from a Sentinel Hub perspective. As some of you might be aware, Sentinel Hub does not do any intermediate pre-processing. All the imagery requested by users is computed from the sources in real time. So this is something we needed to do with the implementation of radiometric encryption. It needs to work fast enough to be compatible with this Sentinel Hub premise. Another thing is that to get quality Sentinel-1 data, you do need a quality global DEM. And as of this presentation, Sentinel-1 data from 2017 and newer is available for processing, as this is hosted on AWS. Of course, once we implemented everything, it was necessary to test and validate the data. Of course, one of the more fortuitous timings of this endeavor was that the Copernicus DEM, which is provided by ESA, was launched last year, so in 2020. And it offers 10-meter resolution in EEA 10 areas, while you also have a 30-meter global version, as well as a 90-meter global version. And one of the nice things about it is that it contains improved and consistent data and does not have any voids or anything similar, unlike RTM. So we decided that we will be using this one. And of course, as mentioned previously, a quality DM does mean quality Sentinel-1 data. And since this is new, of course, for its usage, we needed to implement this in Sentinel Hub. So plenty of work was needed to do that. Here's a simple example of the impact of RTC. So on the left, you have a standard orthorectified image, and on the right, you have a drawing-corrected image. So as you can see, the mountains disappear. Here's an example of the impact of the DEM, and on the left, you have a worse DEM than the one on the right. So you will notice that the image on the right is smoother. It doesn't have as any blocky, patchy artifacts. It is, of course, the preferred choice. On the right, you have the log of the normalized scattering area. This is simply to ensure a nicer visualization, and this is overlaid by the radar shadow mask, which is in orange. So in this image, you can actually see that there is some shadow, but not really a lot, despite the fact that it is in mountainous terrain. On the left is just your standard orthorectified image for comparison. Another thing that we need to do was decide on the processing parameters of each step. So for the digital Earth Africa processing, we decided on a resolution about 20 meters. So this is not the full 10-meter Sentinel-1 pixel spacing resolution, but it is a little less. It will save some space and sufficient for their use. The projection chosen was WGS84, as it is a global projection, and also is quite sufficient for Africa, as it is centered around the equator and therefore has less distortion in those areas. To process this data, we also decided to use data takes instead of each as one product individually, as they are a more logical grouping, and also decided on linear interpolation. Of course, these were only the basic parameters. It is slightly out of scope to consider other things, but there were a number of processing details which were not very well defined. So for those, we needed to discuss what made most sense, and then of course we had to decide. So there were quite a few discussions around that. Then finally, CARD4L products are actually just, you could say, standard Sentinel Hub output with a defined parameter set, but of course these can be changed at will. Another component of the CARD4L products is the metadata, and one of the initial issues we faced was some ambiguity in the spec, since it is, let's face it. And we had to discuss and figure out what was actually meant and what made most sense. Another issue was that some of the details to describe the CARD4L products, like the interpolation, were not part of the spec, so we simply added those. And of course, the metadata generation still needs to be flexible enough to cover different types of products and processing settings. And this is actually simple enough to do for single products, but once you do mass processing on Sentinel Hub, which you can turn upside down just to get it to work, this was also something we just saw and did. The CARD4L tool was created to simplify the product generation for different users, and if you simply use the defaults, you'll get a DE Africa compatible CARD4L product with the included metadata, just like that. Now, one of the nice things here is that you can actually tweak these settings and get a slightly different product, which is still CARD4L compatible. The only caveat is that while you may tweak the settings, tweaking them too much, for example, the eval script may actually break the metadata because it cannot interpret user intent. Of course, we might consider adding different presets later. To conclude, the CARD4L products generated by Sentinel Hub have been evaluated by Geoscience Australia as well as NASA and CEOS for quality, and this was done on different locations around the world. And to keep in mind, while this whole process was initially created for DE Africa, its usage does extend beyond. It can be used by anyone, and for example, NASA is using the products as inputs for the Open Data Cube projects. Another benefit is that since this is in fact the first of its kind, it will help with the CARD4L specification to move forward. And we'd also like to continue discussions with ASF about extending the Sentinel-1 archive on AWS. So we'd like to have the full Sentinel archive, not just data after 2017. So that's that. Thank you for listening, and bye.
Thank you very much, Marco, for that. I think that there was something with the sound file that sometimes your voice was cut a little bit, but I think the message got through well anyway there. We'll move on to the last of the presentations here, which is about JAXA Global L-band SAR mosaics and the activities towards CARD4L NRB compliance. So please. Hello again. My name is Åke Rosenqvist, and I would like to give a presentation on behalf of Takeo Tadono at JAXA's Earth Observation Research Center and colleagues from RESTEC and Tokyo Denki University. We will provide a brief overview of JAXA's global L-band SAR mosaic products and efforts to make them compliant with the CARD4L specifications for normalized radar backscatter. JAXA has since several years back generated global mosaic products from GERES-1, ALOS, and ALOS-2 L-band SAR data at 25 meter pixel spacing. The mosaics are generated on an annual basis, comprising all land areas apart from Antarctica. To date, there are 9 annual mosaics available from 1996 to 2018. Pulsar 2 mosaics for 2019 and 20 are scheduled for a cherry blossom release that is in the March-April timeframe this year. The mosaics are available for public download at the JAXA ERC webpage, free of charge after a simple user registration. The mosaic products can be referred to as analysis ready. However, they are not yet fully compliant with the CARD4L NRB standards. The mosaics are provided in 1x1 degree tiles in geographic lat-long coordinates and comprise of the following data layers. For the measurement data, we have the HH and the HV polarization images that are given as gamma naught backscatter. They have been subject to full geometric and radiometric terrain correction. There are 3 per pixel metadata images included: local incidence angle image, observation date image, which indicates on a per pixel basis the corresponding observation date, and a mask image with information about valid data, no data, radar shadow and layover, and water surfaces. The general metadata is the key point of non-compliance with the CARD4L standards, as it presently only consists of a simple MV header. The file format is generic raw, with the backscatter data provided as 16-bit unsigned integer. JAXA ERC is currently undertaking a major reprocessing effort of all the global mosaic data, and that has presented a perfect opportunity to ensure that the new mosaic products are fully CARD4L compliant. The reprocessed mosaics will feature improved geometric accuracy. They will be composed of data from the year in question only, in order to maintain the temporal and annual integrity of the mosaics. And this is important, for instance, when using the data for change analysis. The mosaics will be provided in GeoTIFF format to accommodate direct ingestion in standard GIS software, such as QGIS or ArcGIS. Regarding the processing and reprocessing schedule, the 2019 and 2020 Pulsar 2 mosaics are processed as we speak, with public release in late March or April as mentioned. The 2015 through 18 Pulsar 2 mosaics are scheduled for the 2nd and 3rd quarter of this year. All Pulsar 1 mosaics, 2007 through 2010, are to be reprocessed in the 2nd half of this year. And in collaboration with the ESA CCI Biomass project, reprocessing of all historical GERES-1 data is also planned. And at the end of this year, a new mosaic product consisting of all fully polarimetric data acquired by ALOS-2 is planned. This is a very exciting product, and we hope that it will help to stimulate new SAR polarimetry applications. This also presents a potential opportunity to assure compliance with the CARD4L Polarimetric radar specifications. CARD4L self-assessment of the Mosaic products is ongoing, including the development of complete general metadata information. The aim is to achieve at least threshold compliance with CARD4L Normalised Radar Backscatter specifications. And the target is to submit the assessment for review by the CEOS Working Group Calval in mid-2021. So I thank you very much for your attention again. Arigatou gozaimashita. All right, arigatou gozaimashita. Okay, that's then we have reached the end of this series of presentations. So if there are any questions from the audience, you're very welcome to type in the Q&A window. I can repeat one of the questions that came up from somebody whose name I cannot pronounce. But concerning the polarimetric matrices provided by CARD4L, they should be in radar geometry. Afterwards, the user has to convert the final product to ground geometry. Would you provide any grid useful for geocoding? Was the question. And actually, the CARD4L covariance matrix images are not in radar geometry, but actually already in ground-based coordinate system. And the objective of that is, of course, to make these data much more, say, easy to use for non-expert users. So that's kind of maybe a little bit kind of the CARD4L in a nutshell, that we really try to make these data more useful. And I should also say that, you know, to a certain extent, maybe some SAR expert users might find some of the CARD4L products not exactly what they would like to have. It is, of course, a trade-off between, say, how to make a product user-friendly versus kind of maintaining all the information of a product. So basically what we're saying is also that we're not asking data providers to replace current products that they have in their catalog or current processing levels. This is something that we would hope that they could add in addition to existing levels, so that all different data users would be able to get the kind of data products that they're interested in. All right. Do we have to start with any questions from the floor? We have 3 questions here, I see. We have first Renan Marujo. Regarding CARD4L requirements, the metadata should be provided as a file, JSON or XML, or could it be a web page as metadata provided by Stack? We only have a recommendation for how the metadata should be provided, and it doesn't have to be XML or JSON or YAML. I think Stack is a format that we would also approve of. There is actually no specification on that, so it's up to the data provider. What is important is that the user can access the data, and that all the metadata parameters are actually included in the metadata file. So I believe that Stack is fine too. I'm not familiar personally with Stack, so I couldn't really say exactly, but I think that should be okay. Then it says here, the CARD4L NRB is tailored to gamma naught with a statement that sigma naught can be retrieved via the per pixel metadata. However, we do have Sentinel 1 sigma naught archive. Does that mean that we have to recompute the archive to get gamma naught in order to for this to be CARD4L compliant, or are there other options around? I guess we will have to look at that. I think that we have said in the specification that it should be gamma naught, but if you would be able to present or provide a sigma to gamma naught per pixel metadata that you include, I suppose that it could be considered. It's not for me to sit here and decide though, but I think that that's something that could be discussed and evaluated on a case-by-case basis. But I think that there should be a way to go between sigma naught and gamma naught. Let me see here, there are efforts going on to specify stack extensions to express the CARD4L metadata in pure stack JSON format. If there are people interested in that, please have a look at this webpage. It would be great to collaborate on that. There is also a PR on optical available. Okay, thank you very much for that information. We'll save that website. We have a question from Tamara. What do you see as a trend and requirements with respect to users leveraging AI on these platforms? Well, I personally have no idea. Maybe I push this question maybe to Brian. Are you on AI or somebody else on the panel?
Yeah, we have seen a number of users very interested in AI. Matter of fact, right now I have a student project going on here locally with one of our teams that a number of students are using multiple data sets for AI in a data cube environment. And I also know of one in Australia as well, a large student-based competition that they're using AI. So definitely, certainly the open data cube and the use of multiple interoperable data sets in a framework like this is very conducive to AI.
Thank you. Okay, anybody else on that? One more comment. Yes.
On the Africa side, of course, we share the Open Data Cube infrastructure, so it's a very similar setup. And I think we're also involved in try to build capacity in Africa to use these data, and there's certainly interest from data scientists and people interested in AI applications as well. So we're hoping to, together with the ODC initiative, we're hoping to bring together these communities through all these different efforts to connect these applications or people who can build these applications on top of our data.
That's great. Thank you, Fine.
At ASF, we also have a small AI group that's working on phase unwrapping right now, but they've already done water masking and cropland detection. So it's definitely something that's exploding. As we get more data closer to each other and more compliant with each other, we'll be able to do more and more things with the AI.
Great, thank you. I see here there is Peter Zellner has said that there are some initiatives going on to map CARD4L to stack and a website here. So thank you very much for that information, Peter, as well. All right, I think those are currently the questions that we have in the chat box. Here we have a new one from Manuel Huber. Is it possible to use feature collections in form of shapefiles to download data products specific for a certain area, like it is possible in the Google Earth Engine? Well, I guess it depends on who you are, to whom you're addressing this question, Manuel. For ASF, for instance, would you be able to provide? Are you providing data only on a scene-by-scene basis, or can a user upload a shapefile and just request data within that area of interest?
Well, you're able to. You can use an AOI in our data search engine. We don't create mosaics, so if something is bigger than a Sentinel scene, you'll get multiple Sentinel scenes. But you definitely can use AOIs in there. Okay. In that interface.
Great. What about Synergize?
Yeah, so the tool that we have allows uploading of a shapefile or KML to define a region. So yes, definitely support that.
Okay. And can you do that also directly in the CARD4L tool, Marco?
Yes, that's correct. I think that's also what Brian was talking about, just the CARD4L tool. But then again, strictly speaking, you don't need the CARD4L tool. I mean, if you just want data, which is maybe not strictly speaking CARD4L compatible, yeah, it works via our API.
Okay, excellent. While I have you online here, well, you're online all the time, but anyway, while I kind of have you on the hook here, I'll also pass on another question that I have for Synergize. So we understand that the Synergize tool now, it is kind of publicly available, so what is kind of the way for new users to get access to the Sentinel Hub CARD4L tool? Can anybody just log in, or what is kind of the approach right now? Because I mean, I know that this has kind of just now kind of developed and released kind of within the past month. So what are kind of the plans for the future for opening up this tool or making the tool available?
I assume this is directed at me, right? Okay.
Maybe.
All right. Because we're teaming with Synergize and Digital Earth Africa on all of this, and it's a bit of a prototype at this early stage. But the plan is eventually to have this tool be available to others to use. Right now, when someone wants to run a test case, it's being done, and I'm paying for the development of some of these small data cubes around the world. If someone wants to consider implementing a larger test case or putting together a pipeline of data for their own, I would suggest contacting Grega and the Synergize team directly, and they'll be able to work that out. We found so far that the costs associated with doing this in the Amazon cloud are very small, less than about €1 for a scene. I did all of Virginia, 1.4 terabytes of data for less than, I think, €2,000 total. And this was a big chunk of data, 3 years of data, every scene over coastal Virginia. So it's a very reasonable and inexpensive way to put the data together in a cloud and in the framework that we want. So just contact me if someone has an interest in creating a small sample data set. I'd be happy to do so.
Just to add here, Grega speaking, as Brian already mentioned me. So basically the CARD4L tool already now is available to just about anyone. And if you log in with your own Sentinel Hub account, you can use it, and Brian will not pay for it, right? It will go from your own subscription. So it's available, and yeah. So, and if somebody does not yet have an account or subscription, they can contact me, and yeah, we'll arrange a test cycle or something.
Wonderful.
Thanks. I didn't know Greg was online. That's great. So Greg, just to be clear, you know, someone with the Sentinel account can log on there and submit a job. Now, I suspect there's some limitation. You know, you're not going to want someone going in creating for all of South America. But is there some limitation, or how once they submit a job, you'll take a look at that and see, the size and complexity?
Well, no, actually all is automatic. Each user has a quota on the Sentinel Hub based on the subscription, but also the trial users have a quota. And then, I mean, as long as the batch request is not exceeding that quota, it will go through. And I mean, when you do a test request, well, when you fetch a request, you can actually get information how much quota it will use. So, so yeah, basically it's all automatic. There is no intervening from our side. And as long as there is enough quota in the account, it will go through.
Fantastic.
Great. And Anya from Synergize, she has just published in the Q&A the link to the CARD4L tool, so there you can click that and check it out. You will need Synergize Hub account though to use it. So maybe then I'll just kind of pass on the question to Fang, because Digital Earth Africa then sit or will very soon sit on almost the entire Sentinel-1 archive, at least from 2017 and onwards, over all of Africa. And all of that data will be free of charge and publicly open. So how can users access that data if they want to try out, say, time series data or whatever over that?
Thanks, okay. So all the data processed by Synergize over Africa will be transferred to Cape Town, to AWS S3 bucket. And as I mentioned, it's all stored as part of the public dataset program. So the access to those data from S3 bucket is completely free. You do not need, that means you do not need an account with Digital Earth Africa or AWS to be able to download those data directly. That said, if you want to experiment using that data through an open database interface, we do provide a sandbox environment where you can also sign up for free and with somewhat limited resource, but you can try out loading the data directly through ODC's Python interface, and then you can try out our existing examples. We're hoping to provide some additional guidance and examples when we have the SAR data available, but we also have other, we have application examples, but you're also welcome to bring your own algorithm and try it out in that Python interface.
Great, thank you very much, Fan. I see we have two more questions in the Q&A. One is from Marco Wolza from Jena University in Germany. Do you have any do you know of any plans to simplify or implement the process of generating CARD4L compliant data via existing open source software projects? No, I am not aware of that, but that is, of course, something that we hope will happen. It would be really great to see, I mean, the Snap tool or something like that implemented to have kind of to spit out CARD4L compliant data. I know that JAXA are working on a tool that can be applied on, you know, they are opening up some of their Pulsar 1 and Pulsar 2 archives. So very soon, all the Pulsar 1 data will be publicly available, and the ScanSAR Pulsar 2 data will be publicly available. Those data will not be exactly in CARD4L format, but JAXA are considering the development of a tool where the user can use the tool to convert to CARD4L formats. But we all, of course, hope that other, say, data providers and developers will kind of catch on and develop these kind of applications. Then we have.
Okay.
Yep.
Can I just add to that? I would say too, from a CEOS LSI VC perspective, that is really kind of the strategy, is to work directly back with the data providers and encouraging them to create these products on all the users' behalf, so all individual users don't need to do it themselves. And so we've been quite active in that realm. I think Brian already mentioned some of the work going on with the Copernicus program for Sentinel-1 data, and I think that's just the in general strategy that's been employed throughout CEOS.
Great. Yep. Thanks. And yeah, we have a related question from Jerry Kolek as well. Do future SAR projects like INSAR Biomass plan to provide CARD4L compliant data? We are, of course, hoping that they will. We don't have any firm commitment yet, but we do have people, for instance, in this CARD4L SAR development team who are also members of the INSAR team. I think, and that's kind of, I think, one of the bottom lines here is that, you know, data providers, you know, it constitutes a significant investment, of course, to start developing CARD4L compliant software, etc. And, you know, data providers will not do that unless they know that there is a demand for this kind of data. So I think it's also for us from the user side, really to make the data providers aware that, you know, CARD4L type of standardized, easy to use data, it is really something that the users want. And so I think that, you know, the more we can make data providers aware of this, I think the better. And I think that, I mean, right now, you know, the NRB products, for instance, has been around just for a bit over than a year, I think. You know, it's always kind of difficult in the beginning before we kind of get the ball rolling, so to say, and people kind of jump on the bandwagon to do this. So I really think that, I mean, if we kind of make sure that data providers are aware of this kind of desire to have this kind of data, I think that we will see more and more of this in the future. So it boils down to us on the user side as well, very much. Okay. There is one question here from Seng Shu. Hi, Brian. You mentioned that Sentinel Hub CARD4L tool will produce Sentinel ARD in 1x1 degree tiles. What is the motivation of using tiles rather than scene-based? And how do you manage the radiometric variations between different orbits? Thanks.
Maybe Greg, you might be able to answer this. We did go round and round about what would be an appropriate way to package the data. I also think this was driven a bit by the Digital Earth Africa team as well. Greg, do you recall the final decision or what went into that? I was a bit flexible on it, but I'm now seeing that there are some people that are interested in scene-based versus a 1x1 degree tile.
Yeah, I can comment on that. So, I mean, first of all, to answer the second part of the question about the radiometric changes in the orbit, I mean, we don't provide, we provide on the data takes, as Marco mentioned. So therefore, I mean, it's always only one orbit, or actually a part of the orbit. We wouldn't stitch the data from different orbits together. This we don't do. In terms of the grid, the decision was somehow technical, because this allows us to optimize the processing a bit more. But then also from the user point of view, we kind of believe that the users are not really interested in the scenes, right? The scenes are there because the ground segment of ESA and similarly are not able to distribute, or it's not feasible to distribute full orbit files. So therefore they split them in scenes. And here we want to basically make it easier for users to don't bother about this stitching. And we simply do this on the data take level, which means that it's always only the data that belong to the same observation stitched together and then delivered in nice chunks, which we feel are feasible for the machine learning and other tools to process.
Yeah, which is, you know, that last thing that the part you mentioned about not stitching together data from different observations. So in a 1x1 tile, we're not going to have multiple scenes or observations in there. So that's important. You know, the way that they're stacked. You might have multiple, you know, 1 degree tiles close together in time, but they're going to be from separate scenes or orbits.
All right. Thank you very much for those comments. We are now at the end of the meeting here. I see that there is one comment here from John Truckenbrot from FSU Jena again here. Hi, just as an advertising comment, the open source software PyroSAR will implement CARD4L backscatter production this year. Feel free to contact me if you want to contribute. I think that's a great comment as well. And thank you very much, John, for letting us know. And I think we will contact you on that. So now we're at 1/4 the hour. So I would like to just wrap up by first of all thanking all the speakers for their contributions and time to invested in this. I think we had really good presentations and good discussions. And I would like to thank also the participants for taking the time to join in here. I saw that we had 98 participants in total here. So that means that we actually had 150 over the two webinars today, which I think is a fairly good number. And I'd like also to thank Matt Stevenson for the technical support here to help this kind of get running. And finally, also Digital Earth Africa for hosting the meeting on their Zoom link here. So before I finish here, any final comment from any of the panelists, from Steve as a co-lead?
I guess I want to echo your thanks to everybody for participating. And I would say too, there's several projects that are underway right now. The Digital Earth Africa, there's a CEOS coastal project, and there's some work going on in OGC as well, where this interoperability of both optical and radar products is starting to happen. And I think we're really anxious to see how well those do integrate and how the specifications may evolve over time to better support that. That is one of the goals of CARD4L after all. So thanks everybody, and thank you, Oke, for leading us on these two webinar sessions. Really appreciate it.
Yep, thank you very much. And thank you everybody. So good day and good night and good morning, good afternoon, everybody. And by the way, we have recorded the webinar, so we will post the link to this webinar on, I believe, on the CEOS ARD webpage. Great. Thank you very much, everybody.